Hi, my name's Jervis, and I work on the go-to-market team here at Iterative, focused on growth right now. So specifically helping data scientists and machine learning teams at organizations use our open source tools in their MLOps programs and learning about their requirements and how they develop their models and what tools they use. So today I'll be going over 3 requirements that I've seen lead to better MLOps for teams based on what we've seen in our community and how everybody uses our tools. And so for more context, Iterative, where I work, is a venture-funded open source company. Our community has a little bit over 5,500 members and over 200 contributors across our open source tools for data scientists. So we're all about MLOps here and how to improve it for data science teams. We work with a lot of people in the community to answer their questions and see what their use cases are around our tools and how kind of they approach just building models in general. A lot of their feedback goes back into improving our open source tools here at Iterative. So the 3 requirements that I'm about to talk about are based around that feedback and how others approach building models, the MLOps process at their companies, things like that. And I recognize that MLOps is a pretty broad and encompassing term. So specifically, the 3 points that I want to go over today center more around model development and the data that models use and deploying those models. So all around, the data sets, the models that are using those data sets, and then when you're using your compute resources to deploy these models to train and stuff. These are things we've seen around how Iterative's open source tools are used. And so I also know that the audience is probably pretty diverse today. So this presentation is meant to be a bit more general and to give you things to think about when you're looking at maybe improving or kind of just streamlining some of your processes when you're building out your models, whether you're in a commercial or academic environment, because a lot of what we've seen and probably what I'll cover around collaboration and reproducibility of models is relevant universally, I think, to make things easier when you're working on models and creating them. So this is all around looking at how you're managing data sets, your experiments, and your compute resources when you're training your models. For the agenda, I'll go over how we see MLOps in organizations today, what's changed in data science teams, and the 3 requirements. I'll end by going more in depth around the tools that Iterative makes for MLOps to kind of help address these requirements, as these are kind of what we've seen in the marketplace today and how data scientists are working today. So to start off with, back even 5-10 years ago, maybe, as organizations were learning how to build machine learning models, there were a lot of questions around how to build one to effectively support the applications, the services to be delivered for customers, if you're in a commercial setting, for your users, or for kind of whatever you're trying to do. And not only that, but also even around getting the expertise necessary to do so, because data science as a field was less mature than it is now, obviously. So there were questions even around finding actual data scientists or training them in more, whether it's a commercial setting or an academic setting, but actually like training them. These days, they're like, obviously, there are a lot of courses and classes devoted to data science and model building, and they're all really good and accessible. And events and organizations, even like Data Science Go, all center around this topic. So these days, there's a lot of support around it. There's also a lot of standard best practices around getting a model from conception all the way to production in the present day. And even the term MLOps has emerged to match with standard DevOps lifecycle, with the standard DevOps lifecycle in software development. So what we're seeing now is the next major challenges are centered more around how to make machine learning teams more productive and efficient, and how to optimize the the MLOps process in general. And so as the models being built become more complex and data science teams at companies get larger and more people are involved, things get more complicated. Like you have multiple teams working on multiple models, and they need to all collaborate with each other, work with each other so that everything works together when it's actually deployed and in production. And all that comes, and also all that comes after that in terms of kind of monitoring and improving on these models. And so with that comes questions around how to standardize processes, share knowledge around models, and make sure information gets passed along and doesn't just, all reside in one person's head. What's happened to kind of address this is that vendors, a lot of public cloud vendors specifically and especially, have come out with their own tools that are specific to their own products and ecosystem. So cloud companies have full-fledged ML platforms like Amazon SageMaker, Google Vertex AI, Microsoft Azure ML. They all have that for you to use when you're using their infrastructure to train your models. Or what's also happened is you as an organization, as a team, as a group, may have custom built tools of your own to help automate things, whether it's your own infrastructure or in public clouds like AWS. And so there's a whole ecosystem or sets of tools and approaches to choose from out there. But each kind of approach tool that you choose has their own kind of trade-offs, I would say. For relying on like a public cloud vendor like Azure ML, you'll get kind of a seamless integrated experience, but the trade-off is a closed ecosystem, right? Everything is built for that specific cloud and or vendor. And so you have to go all in with it. A lot of times, and a lot of companies, even if we're talking more commercial settings, especially at larger ones, your infrastructure cuts across clouds. You're going to use multiple cloud vendors, multiple clouds, and might even have your own data center with hybrid approaches or your own resources. And so by using a specific cloud vendor's ML tools, you're kind of stuck with them. But on the other hand, custom and homegrown tools you create at your own organization work well because you customize them for your specific needs and use cases across whatever infrastructure and resources you're using. But the downside is you spend a lot of development cycles and resources to maintain and build these tools, and also have to keep up with the latest advances with the infrastructure that you choose. And so at Iterative, again, to reiterate, we kind of take the approach of being more open and cloud agnostic or even multi-cloud. And so the tools and the requirements that we keep in mind around them are to work across clouds, regardless of what you use, and for the tools to be open for customization to meet the specific needs of each of your teams, while still, providing a foundation and base in an open source kind of manner. We have a philosophy around kind of working with existing solutions you have around software development or DevOps processes and extending them to MLOps, so you don't have to be working from a blank slate as you scale out your data science projects, your teams, whatever. Can go more into this at the end, but this is a good transition to the actual requirements portion of the presentation. So to kind of close the loop on the actual requirements, they're all around collaboration. Back in the day, working as an individual data scientist on your models meant a lot of manual tracking, digging through wherever you put your notes and emailing experiments and information to others. And before you even shared, you kind of had to go back and look through your notes, make sure everything was correct, and especially if you're sharing with management or, higher members on the team. So things like what specific version of a data set a model was trained on, how much time, the environment, libraries, and what versions of them, and even kind of what machines or resources were used for training, all needs to be compiled. And as an individual, you might even have your own local kind of compute resources, like a local GPU or something that you use to train your models. But now that we're in kind of like present day, team and collaboration requirements are here because MLOps is at scale. And so the previous way of doing things are a little bit more unwieldy, slow, and error prone because they're so manual a lot of times. The example I'd give might be around compute resources. these days, which are being fairly centralized. So when models need to be trained, there needs to be better visibility and automation, so your teams can plan around resource management. Another one would be, it also gets kind of unwieldy when you have a bunch of Jupyter notebooks per project, right? If you have a lot of projects. And so the problems working with ML models at scale and across teams today revolve a lot around reproducibility and governance. You can see how you want to see how models are built, what the artifacts and associated data are, and you kind of want to be able to do it in a way that doesn't rely on digging through one email or presentation or a Slack message to get to the right data that you're not really sure is correct. And so the 3 requirements I'm going to quickly go over now are around metrics, data, and resource management. And so the first one for this improving kind of your data ops or your ML ops is metrics need to be shareable and accessible. Metrics like those around performance need to be shareable and accessible in a centralized way and brought into the process of model development. And so this is a core collaboration requirement for your team so that you can kind of share the knowledge, not through email or Slack or something, and for each of your teams to kind of track progress and performance across your models and compare. So you can kind of get better models into production across your apps and services faster. And so what I mean by that is kind of giving you a dashboard where anyone on the team can see and share and see how your models are actually working and the associated data versioning with it. The example I would give here, which you can kind of see, is around running hyperparameter searches and generally trying lots of models to find the best one, which might differ depending on a lot of factors like which business metric you care about or ML metric you care about, how stable the model is, or how complex it is. And so when you need to compare against any of these, we need to be able to compare based on any of these criteria and recover kind of the best one along with everything needed to reproduce it, whether that's the data, the code, pipeline infrastructure, things like that, for various reasons, for QA, rebuilding with newer data, deploying it, things like that. The second requirement kind of leads us to data needing to be automated. Data sets in storage, like if you do it in Amazon S3 buckets, let's say, aren't just static and unchanging anymore. Like if you're tracking your customers or your users, they bring in new and different data every day. And so we're kind of in a world of really dynamic data sets. So it's important to track data versioning for your specific models as you work to improve them. It's not a one and done thing. Once a model moves into production, your team kind of continues to monitor the model and tweak it for incremental improvements and being able to manage and track the data sets that each variation of a model is trained on. And so that's critical to getting them to market in the fastest possible time. This screenshot shows a dashboard where you can kind of specify storage like S3 buckets and add the data sets where you can kind of find the details around them so you know which actual specific data set you used. The guiding principle here is around data changing all the time. We're adding new data sources. We find data quality issues when we're training our models, or we just get newer data in general. And so we need to be able to keep track of what version of data each model and pipeline uses and make sure we use the latest version for our models or roll back if we find an issue and do that in a really easy kind of manner. Finally, the last requirement I'll talk about today is on the compute automation side and moving, just beyond your local GPUs, your specific, your own resources. Being able to automate and trigger jobs for cloud resources like Amazon EC2 instances can really help free a lot of time up for data science teams, as well as help with just resource planning and use in general. You'll get more kind of auto-generated reports showing all the changes in specific runs of experiments, as well as be able to provision and scale down up compute like EC2 instances without wasting any resources. The example I'd give here is needing cloud resources for more powerful and resource-intensive models, but using cloud provider frameworks requires rewriting everything and buying into their whole stack. and managing cloud compute resources on your own wastes time that could probably be better spent improving your models or on more strategic initiatives on your team. So this goes back to reproducibility. We need compute resources to be reproducible so we can retrain them on the same infrastructure without having to debug environment errors and just being able to use your resources more efficiently. You can kind of see the trend here in terms of reproducibility. The data, the models, and even the compute resources need to all be reproducible and tracked for, general and full collaboration on your in your data science teams. And with that kind of, summarizing everything, the requirements I've talked about just lead to a lot more fast kind of time to market with your models, whether you're serving users, customers, putting it into your apps, whatever you're building, whatever service you're building. And so teams get a lot more collaboration and governance because things like reproducibility, reliability of your models, explainability and knowledge sharing, and just general automation will make just everything run better and be more efficient. Obviously, that we kind of take a lot of this feedback that we've gotten from our users from our open source tools. And so to build a little bit more on the iterative approach, we have 2 open source tools, DVC and CML. And we also just released Studio, which is an enterprise product that gives a layer of kind of visualization over our open source tools, DVC and CML. And so all of these are built on existing software engineering solutions like Git. And so we're kind of just extending best practices from the DevOps side to MLOps without having you to go all into new tools that might be closed or walled gardens, right? And so our kind of goal is to make data science teams more successful by extending Git, GitHub, so that your data science teams can be just as efficient as software development teams. And so happy to kind of discuss this approach and what this means with everyone. But this is kind of, feel free to kind of visit our websites here, DVC, CML. DVC is our most popular open source tool. You can see is a lot of the screenshots that I used in the presentation to go over the requirements were from the tool, obviously, to kind of explain why the requirement was important. But this is just a good kind of information if you want to go visit some of our sites to think about in terms of just making your processes a little bit better and streamlining them. And with that, I know I'm almost running out of time, so I'm going to take any questions and anything else with everybody.
Jervis, thank you so much for the wonderful presentation. If you guys have questions for Jervis, go ahead and drop them right there into the comment section and we will get to them. In the meantime, why don't you guys take a screenshot of this right here, tag me, tag Jervis, all the social medias, hashtag that DSGO virtual. I want to see my notifications just light up like a Christmas tree, guys. So make sure you're doing that for me. Jervis, I'm quite curious here about how can we use experimentation management tool to help us connect model metrics to business outcomes or business KPIs?
I mean, yeah, I think this is, so what I'm talking about from the presentation was all about kind of just optimizing your processes and making things easier and faster. And so when you saw the benefits that I talked about in terms of going to market faster, time to market faster, that helps kind of improve your business kind of metrics and outcomes, right? Because when you're measuring, when you're trying to improve a specific business metric for your app or service, you're going to be like, okay, so how can I iterate on this faster to see which model works the best and what I need to change faster and quicker. And so when you're using more automation in your tools, in your processes to kind of find the answer to that, everything's just faster and better.
Do you have any resources or keywords or kind of definitions for those of us who are moving into data science or transitioning? What should we keep in mind, in terms like these ideas like concept drift or things like that, model drift? do you have any research for us to go to learn more about that, to make sure that we are accounting for that as we're building models? If that
Yeah, I feel like, we've seen a lot of the previous presentations give a lot of resources on a lot of the technical kind of stuff.
Mhm.
And I think there are a lot of public ones out there, whether that's the Udemy course that we heard about in the previous presentation and stuff like that. So just going to those sites and, with you guys and going to these meetups and events, I think that's a really good place to go. And you'll see with a lot of the, especially the open source tools like DVC and stuff, we have full communities like on Discord and Slack channels and stuff like that. So, and I think part of learning and getting up to speed with a lot of data science kind of terminology and stuff is talking to other people and participating in the community and just asking questions. Because from what I actually recently joined Iterative, so this is also pretty new in terms of Iterative as a company, but I've seen that the open source community is really helpful and very nice in terms of just, if you have questions that you want to ask and be answered, that people are really open.
Would DVC also work across other Git platforms such as Assembler?
Yeah, so DVC is built to work with all your kind of Git stuff. And so it's pretty open source. It's open source, so it's pretty kind of customizable as well. So if you have tools and stuff that need that you think we need to work with, feel free to kind of reach out to us even to ask questions.
Jervis, thank you so much for taking time out of the schedule to give us this wonderful presentation, man. Really appreciate you swinging by.